Hello, my name is Chris Andrews. I'm the lead product manager for Autodesk's infrastructure conceptual design products, including Land Explorer and an experimental technology preview called Project Galileo. Today I hope to give you a rapid overview of technology developments at Autodesk that are driven by several years of research into requirements for 3D, sketching, and analysis at geospatial scale across the engineering, architecture, and GIS domains. To start off with, let's take a look at a user in Project Galileo navigating through a 3D model of 140 square miles around the city of Boston. We've heard from many of our research partners that the industry lacks basic tools to grow 3D urban scenes from available 2D data. Using Galileo, we can demonstrate that a visually compelling environment can be created from freely available 2.5D GIS data, such as the data used to grow this scene. Many planners, architects, and their customers are rejecting static, rendered 3D walkthroughs. Our research suggests that these users want the ability to freely navigate within large models to see high-fidelity views of any part of the built or natural environment where they will be investing in infrastructure change and renovation. For integrated iterative project planning at the scale of large infrastructure projects, a user needs to be able to examine one part of a large model, zoom to a completely different area, and then to begin working in the new area at the same level of detail as at any other location in the city. We're exploring this concept with Project Galileo. Some users have high-quality, more realistically textured models for urban assets, such as this pictometry data from the city of Vancouver. Users want to be able to use the quality of the models that are available and that suit their current problem set to model and represent their local environment. As you can see, we're experimenting with using these digital assets as 3D GIS objects with their own individual properties that can be selected, queried, and displayed. Beyond simple navigation of semi-realistic 3D scenes, we're investigating techniques for visual data analysis. In this scene from Boston, we've mocked up some sustainability information and are showing 160,000 buildings highlighted according to attribute values. The model is seen at lower level of detail when zoomed away from the city. But we're also experimenting with the ability to view attribute-based highlighting against different levels of detail for road, building, and other asset facades. We are experimenting with the use of imaginary objects to represent area and neighborhood effects. Here is an example of some simple transparent balls that have been colored and scaled according to attribute values. Ideally, a user should be able to represent both actual assets and imaginary boundaries, linear features, and other geometric effects against BIM or GIS quality assets inside an environment like Galileo. Now let's take a look at a 10,000 square mile terrain for part of Northwest Washington State. We're investigating techniques to easily allow a user to create very large models and to visually inspect infrastructure development within those models for aesthetic and line of sight effects. We've found that some users want to see real-world assets represented in schematic quality, such as these trees, buildings, roads, and rivers, rendered in a simple shape and color palette. In a single workflow, a user should be able to examine a particular scene from a schematic view in wireframe and in a semi-realistic view to gather different impressions of the conditions or impacts of change at a site. Now let's move to another version of the City of Vancouver model, this one grown from 2.5D GIS information, and let's take a look at actually modifying the model data in the Galileo environment. Here you can see a user bringing a civil model in to change the grading of a site. Next, the user brings in a GIS-derived site plan. You can see the user's changed pavement and grass types and now has actually sketched 2D roads that blend into the 2D road network, but appear as 3D in the scene. The user can sketch buildings, trees, water, coverages, and other assets to develop a conceptual scene for infrastructure that might be built in the future. Once sketched, 3D assets can be modified. As in this case, we've changed the roof height and now the roof color of the buildings in this campus that's been added in. Next, the user dresses up the scene by adding some trees, and then is able to freely navigate, viewing the buildings at the same level of detail quality as any of the other buildings in the environment. We have certainly heard from our research partners and users that interoperability is a major pain point for Autodesk customers. Here you can see a user has opened the city model information from Autodesk Project Galileo in any FDO application such as Map3D and is able to see, inspect, and even edit the information in that other environment. Let's take a quick look at Autodesk Project Vasari, a related conceptual design application being created by the Buildings Group. Vasari is focused on sketching for individual buildings and small campuses, and as you can see is integrated with a variety of conceptual energy analysis tools, including a workflow that involves sunlight analysis, surface radiance analysis, and can even generate detailed reports on environmental conditions for the building. We're experimenting with combining reports from multiple conceptual designs and also with techniques such as computational fluid dynamics for wind analysis. Let's take a look again at the City of Vancouver model, where we sketched in a campus before. We recognize that an important value that Autodesk brings to customers is the ability to create both conceptual models and detailed designs of proposed infrastructure that will be built or renovated in the future. Here you can see a user has brought in an FBX exported from Revit of a detailed building model for the Autodesk Toronto office and embedded it right here in Vancouver. You can see that after importing the detailed model, the user can use Galileo's sketching tools to refine the scene. And then the user can actually import additional information, such as underground utility information, to see how the utilities will intersect with the proposed site. Beyond the import of detailed models, we've given the user the ability to experiment with different visual techniques to present and walk through their proposed design. Project Galileo and Project Vasari are all about giving users the ability to explore concepts and experiment with them in the context of real-world information, such as this model of Vancouver in the background, or the wind, weather, and humidity information available through Autodesk Climate Server that's part of the Sustainable Design package in Vasari. Thank you for taking a look at Autodesk Project Galileo and Project Vasari. I encourage you to check out both of them. They're live on the labs at labs.autodesk.com. We would love to hear your feedback and see screenshots. Thank you very much.